Hello students, today we are going to see here oxidation and reduction of aldehydes and ketones. First of all, we will see here oxidation of aldehydes and ketones. Aldehydes and ketones both are oxidized to carboxylic acids using different oxidizing agents like dilute HNO3, KMNO4 or acidified potassium dichromate means K2Cr2O7 and mixture of K2Cr2O7 and dilute H2SO4. Such type of the different oxidizing agents are used for the oxidation of aldehydes and ketones. First of all, we see the oxidation of aldehydes. Here, when aldehyde is, general reaction is like this. When aldehyde is oxidized by using oxidation means addition of nascent oxygen by using K2Cr2O7 and dilute H2SO4 acidified potassium dichromate, then there is a, see this one, reaction takes place like this. This oxygen atom combines with this H, formation of OH group, and here is OH group is attached to this carbon atom, and in this way it is aldehyde. We can convert aldehyde into, it is carboxylic acid, or C double bond OH is the general formula of carboxylic acids. In this way, now instead of this K2Cr2O7 and dilute H2SO4, we can use different oxidizing agents like dilute HNO3, KMNO4 also. Here now, after this we will see the oxidation of ketones. Here now, oxidation of ketones. Ketones resist the oxidation because in oxidation of ketones takes place through the breaking of CC bond. Carbon मधला bond break होतो, and to break such carbon bond, strong oxidizing agent is required. Therefore, strong oxidizing agent like chromic anhydride or chromic oxide CrO3 is required here. Chromic acid anhydride CrO3 oxidizes ketones into carboxylic acids with less number of carbon atoms than starting ketones. The obtained acid contains one carbon atom less than that of starting ketone. Here now, when the general formula of ketones is RC double bond OO, when it is oxidized by using CrO3, it is a strong oxidizing agent. Here now, this much part, addition of nascent oxygen takes place here. The bond between this carbon and this alkyl group, it breaks here, and it is to be get converted into RC double bond OH. हा part RCOH मध्ये converted, दूसरा alkyl group इथून bond present RCOH मध्ये convert होईल. It gives two, if these two alkyl groups are different, then it gives a mixture of two different carboxylic acids. If these two alkyl groups are similar, it gives only one type of the carboxylic acid. Here, in this way, we can convert carboxylic acids into, we can convert ketones into carboxylic acids by using CrO3 as a oxidizing agent. For example, I have taken here example, if both alkyl groups are similar here, see, example is like this, acetone or propanone. Now this on oxidation by using CrO3, it gives two molecules of CH3COOH. Here the bond between this carbon and these two carbon atoms breaks here, and it gives CH3C double bond OH, two molecules of CH3COOH, and it is acetic acid. In this way, we will get here, if these two alkyl groups are similar, it gives only one type of acid. And if these two, if suppose mixed ketone is there like this, CH3C double bond OC2H5. Now here these two alkyl groups, it is ethyl, it is methyl. These two alkyl groups are different from each other. If such type of the ketone is taken and if it is oxidized by using CrO3, then it gives a mixture of, here the bond between these two carbon atoms breaks here and it gives CH3 C double bond OH, this much part it is converted into CH7. Here again this bond breaks, or another possibility is it gives C2H5 C double bond OH. It is acetic acid or ethanoic acid. And another compound is it is propianoic acid. It gives the mixture of two different acids. If here these two different groups are, if the ketone contains two different alkyl groups, it gives two different carboxylic acids. If both alkyl groups are similar, then it gives only one type of the acids. It is regarding about the oxidation of ketones. Then after that, reduction of aldehydes and ketones. Here now, the first one, there are different reducing agents are used. First of all, Zn Hg and concentrated HCl, such as reducing. And another one is hydrazine NH2. Another reducing agent is hydrazine, and that is to be followed by the alkali in the presence of strong solvent like ethylene glycol. That reduction is known as Wolff-Kishner reduction. And when aldehydes and ketones are reduced by using such type of the reagent, that is ZnHg, zinc amalgam and concentrated HCl, this reduction is known as Clemmensen reduction. Here the peculiarity of this Clemmensen reduction is that in both these reductions, Clemmensen reduction and then after that we have to study Wolff-Kishner reductions. In both these reductions, this C double bond O group, it is to be converted into CH2, means hydrocarbons. C double bond O group plus 4 hydrogen atoms will be required here in the presence of Zn Hg and concentrated HCl. It gives here the bond between these two, the bond here is a double bond between carbon dioxide. Both these bonds between this carbon oxygen breaks here, and two hydrogen atoms are linked to this carbon atom, and we will get here CH2 group. It means that C double bond group it is to be converted into CH2, and this oxygen atom combines with another two hydrogen atoms and gives H2O, that is H2O as a byproduct. In this way it is methylene group. In this way we can convert aldehydes and ketones into hydrocarbons or alkanes. Clemmensen reduction is used to convert aldehydes and ketones into hydrocarbons. I have taken here general example. Now here, for example, in our book such type of the example is given, that is propion aldehyde CH3 CH double bond O plus 4H, पुढे जागा नसल्यामुळे मी खाली लिहितोय असं, in the presence of Zn Hg and concentrated HCl. Here is it gives now the bond, double bond between this carbon and oxygen atom. It breaks here, and we will get the structure like this: CH3 CH2 CH, and this carbon atom it is bonded to two hydrogen atoms like this, plus this oxygen combines with two hydrogen atoms to give H2O, CH3 CH2 CH3, that is propane. It is alkane. Alkane is obtained, that is propane is obtained, or hydrocarbon is obtained. Similarly, here another example here. Now I have taken here the same example here. Now here, if acetone is taken, it gives CH3 CH3 C double bond O plus 4H in the presence of Zn Hg and concentrated HCl. That is reducing agent. 4 hydrogen atoms will be required here, and here the bond between this carbon and oxygen breaks here, and here CH3. Here this carbon atom it is attached to two hydrogen atoms plus H2O. Again it is propane. In this way we can convert aldehydes and ketones into alkanes by using this Clemmensen reduction. Write a note on Clemmensen reduction, such type of the question that can be asked in the examination. Or how will you convert C double bond O group into CH2 group? असा सुद्धा क्वेश्चन मागे विचारला गेलेला आहे. हाऊ विल यू कन्वर्ट C double bond group into CH2 group? Then you have to write this reaction. Now another reduction by using Wolff-Kishner reduction by using hydrazine. That reduction is known as Wolff-Kishner reduction. Here is same. The product obtained in the Wolff-Kishner reduction is same as like that of Clemmensen reduction. सेम क्लेमन्सन रिडक्शन सारखाच प्रॉडक्ट मिळतो, बट द reducing agent is different. Here by using hydrazine, we know the formula of hydrazine, NH2. By using this hydrazine, such type of the reduction, now this reduction takes place in two steps. In the first step we have to do the reaction with this hydrazine, and then in the second step we have to do the reaction with this alkali and ethylene glycol as a solvent. Ethylene glycol as a strong solvent. Now here aldehydes and ketones are reduced to hydrocarbons, and that is alkanes, by using hydrazine and base KOH and solvent ethylene glycol. Now we will see example. Here now again here general example is here now. Such type of the carbonyl group that is present in both aldehydes and ketones, C double bond O. Now it reacts with hydrazine, means formula of hydrazine is like this, NH2, याला आपण असं NH2 इकडे लिहिलं तर काढतं. This oxygen combines with these two hydrogen atoms and it gives here मी अशी खालती लिहितोय, it gives C double bond NH2 plus H2O. It is hydrazone. Now this hydrazone on treatment with KOH in ethylene glycol. Formula of ethylene glycol मी तर लिहिलेला नाही आहे, but the formula, we know that formula of ethylene glycol, that is CH2OH. Formula of ethylene glycol like this, CH2OH. Instead of this ethylene glycol we can write the formula also here like this, CH2OH. Now this here now again here, after doing the reaction with this KOH and ethylene glycol, here the bond between this double bond between carbon and nitrogen breaks here, and here two hydrogen atoms are attached to this carbon atom, and this C double bond group, it is to be get converted into CH2 group plus nitrogen gas is given out. Reaction पुस्तकामध्ये अशी दिलेली, तुम्हाला बॅलन्स्ड रिएक्शन लिहिण्याची गरज नाही आहे. अगेन इट इज alkane, hydrocarbon, or it is an example of alkane or hydrocarbon. Now for example here, when acetaldehyde, particularly here I have taken here carbonyl group, it is a general reaction. Now for example acetaldehyde, CH3CH double bond O plus product is same as like to that of Clemmensen reduction, but the reducing agents are different. This oxygen combines with these two hydrogen atoms and it gives CH3CH double bond NH2. It is acetaldehyde hydrazone. This acetaldehyde hydrazone on treatment with KOH alkali and ethylene glycol CH2OH. Here the bond between this carbon and nitrogen, double bond between this carbon and nitrogen breaks here, and we will get here this carbon atom, it is attached to another two hydrogen atoms and it is get converted into CH3 bond CH3, that is ethane plus N2 gas. These two nitrogen atoms combines and eliminated in the form of N2 gas. Here after that, now it is a, I have taken here acetaldehyde, we can convert in this way, we can convert acetaldehyde into ethane. Here now ethanol into ethane. Another example here, I have taken here one more example, propanol, C2H5CH double bond O. It contains one more carbon atom than that of acetaldehyde. Therefore, it gives alkane with one more carbon atom than that of ethane. That is, instead of ethane, it will give propane. Propanol is taken here, C2H5CH double bond O. Oxygen combines with these two hydrogen atoms and it gives hydrazone. That on treatment with KOH and ethylene glycol gives propane. There is one more example, acetone is taken here. Acetone, it is an example from ketone. When this acetone is heated with hydrazine, it is hydrazine, it gives hydrazone, acetone hydrazone. Here this oxygen combines with these two hydrogen atoms, formation of H2 molecule takes place. That will be the byproduct. Here hydrazone on treatment with KOH ethylene glycol, it gives CH3, that is again propane. I have taken one more example, that is from ketone, that is ethyl phenyl ketone. Here it is ethyl group, it is phenyl group, and it is ketone, ethyl phenyl ketone. NH2 bond NH2 hydrazine. Reaction is here now. Here this oxygen combines with these two hydrogen atoms and reduce, मी वरती लिहिले CH2CH3, C double bond NNH2, and this compound, it is hydrazone on treatment with KOH and alkali like KOH and ethylene glycol gives here the bond between this carbon and nitrogen breaks here, and here is this carbon atom attached to two hydrogen atoms, and we will get here CH2 CH3. हा carbon CH2 मध्ये convert होईल, CH2 CH3, that is N-propyl benzene. In this way we can prepare alkanes by using this Wolff-Kishner reduction. And there is one more reaction, that is, and that will be the last one from that aldehydes and ketones, electrophilic substitution reactions. Electrophilic substitution reactions of aromatic aldehydes, that is benzaldehyde. Now here the difference is that before this we have studied alcohol, phenols, then aromatic alcohols, phenols. In phenols, and here in these aldehydes, difference is that this CHO group, it is an electron withdrawing group. Difference is that in phenol, that OH group, it is a electron donating group. Electron EDZ means electron donating group. It is electron withdrawing group. Whenever electron donating group is attached to this benzene ring, it is activating group, it activates ortho and para position. Therefore electrophilic substitution reaction of phenol takes place at these two positions, ortho and para. But whenever electron withdrawing group is attached to this benzene ring, it deactivates these ortho and para positions. Here deactivate होतात, and it therefore the reaction takes place here at meta position. It is important. Now you have to remember this one. Whenever aldehyde is there, aldehyde group is attached to this benzene, we have to attach the substituent at meta position. Electron donating group is there, we have to attach the substituents at ortho and para positions. Therefore again here in aromatic aldehydes and ketones, electron withdrawing group aldehydic and ketonic group is present. Hence substitution takes place at meta position. They give nitration, sulfonation, halogenation reactions. मी इथं फक्त पुस्तकामध्ये सुद्धा एकच रिएक्शन दिली म्हणून मी इथे घेतलेली आहे. नायट्रेशनची रिएक्शन पुस्तकामध्ये दिलेली आहे. हिअर नाव इन दिस नायट्रेशन वेन benzaldehyde CH double bond O is treated with nitration, means always we have to do the reaction with concentrated nitric acid in the presence of concentrated H2SO4. Then now here aldehyde group हा फंक्शनल ग्रुप आहे. त्याच्यानंतरची पोझिशन म्हणजे आर्थो असते. इथलच्या या पोझिशनमध्ये ही मोठा पोझिशन आहे. हेच जर स्ट्रक्चर सेम स्ट्रक्चर जर मी aldehyde ग्रुप इथं जर काढला असता असा CH double bond O, then it is meta position, it is ortho, it is para, it is ortho meta para. Therefore if we have drawn the CHO group here, then we have to attach the NO2 group at here. It is a meta position, therefore it gives the structure like this, CH double bond O, and here is, if CHO group is here now, CHO group is here now, CHO, it gives NO2 group is attached to this position, and if such type of the CHO group असा जर स्ट्रक्चर काढलं तर NO2 group इथं अटॅच करावं लागेल. Meaning is the same, it is ortho position, it is meta nitrobenzaldehyde, it is meta nitrobenzaldehyde. In this way it is a nitration, it is regarding about the nitration. Similarly तुम्ही होमवर्क करायचा आहे. Similarly you have to do the reaction, that is sulfonation reaction as well as halogenation. Sulfonation मध्ये काय होईल, here instead of this NO2 group SO3H H2SO4 सोबत रिएक्शन करा. Reaction with concentrated H2SO4 here, SO3H group is attached to this position, that is meta position, instead of this NO2 is SO3H. And then if halogenation is there, Cl2 घ्या, Cl2 Br2 घ्या. Br2 जर घेतलं तर at this position instead of this SO3H, that is it gives meta bromo benzaldehyde. Such type of the reactions, या दोन्ही reactions तुम्हाला तुमच्या नोटबुकमध्ये करायच्यात. With this we have completed reactions of aldehydes and ketones. Today we stop here. Thank you.